Hello, I'd like to welcome you to our digital classroom. I'm Jerry Winslet, along with Jason Leonard. We're going to get to him in a moment, but this is the monthly live class. Before we get started on our class, I want you to type your name and how many people are watching with you. You can use the chat feature, which is on the right-hand side of your screen. If you have questions during the class, you can type them in using that chat feature. You don't have to wait until the end of the class. We'll have a question and answer segment before we sign off. So let's go ahead and get started. Now, today's class is on NAECA III and how it affects residential electric water heaters. What NAECA III is, it's a third installment of a plan that dates back to 1987 to increase the energy efficiency of major home appliances like TVs, air conditioners, and water heaters. The NAECA energy standards have saved consumers billions in lower household energy costs. NAECA III is expected to save consumers an additional $63 billion in smaller electric and gas bills. Now, these are significant savings in operating costs. The biggest impact for us, though, is simply that water heaters will get a couple of inches larger. And that means that the size of the space will determine what size water heater will fit. Now, in the vast majority of cases, a NAECA III water heater will fit in the same space as that old water heater. But, you know, last month we talked about gas water heaters and how NAECA III affects gas water heaters. Let's talk about electric water heaters. You know, we talk about them getting a little bit larger and all that, but what are we trying to achieve here, and how are we doing that?
Well, like you said, NAECA III is nothing new, okay? This goes back to 1987. It was an Energy Conservation Act that started in 87, and we just happened to be in the third phase of that. And its whole goal was to increase the efficiency of home appliances. Now, in water heaters, what that means for us is higher EFs, right? That EF, that energy factor, we're raising the standard of that EF across the board. If we can look at the graphic here, we can kind of see what we're talking about in terms of where this chain comes into play. Now, most of you are aware of our conservationist line historically that had a 0.95 energy factor, which was the highest that we offered.
Now, the higher the number, the more efficient the water heater is.
The higher the number, the more efficient. Okay. Now, that number, when we talk about EFs, on its own, that number doesn't mean a whole lot.
Right.
Basically, it is everything like standby heat loss, thermal efficiency, R factors, all these things roll into this magic number, this EF, that on its own doesn't mean a whole lot. But what it does is gives us a benchmark that now we can compare one water heater against another water heater in terms of overall efficiency.
Okay.
That's really what we're talking about. Now, historically, like I said, our conservationist line had a 0.95, which was our higher energy efficient water heater. Now we go back to the graphic and we can see that our 30, our 40, and our 50 are now 9.5 across the board.
Yeah.
So we don't have anything in our product line that's going to be below a 9.5 or a 9.4.
Okay.
The big deal is, notice our 60, our 80, and our 120. Look what happens to the EFs once we get into that size capacity.
They're really high.
Yeah, 1.98 on a 66, 1.97 on an 80. There's really no way to get that type of EF in a standard electric tank type water heater. There's just really no way that you're going to get there. The reason is electric water heaters are pretty much as efficient as you can get in terms of thermal efficiency. We have 100% submerged elements.
Yeah, that's what I was going to say.
Yeah, so all the heat that we're making on the element, because it's submerged, goes directly into the water. So there's really no gains that we can get in terms of thermal energy, thermal efficiency. So the only gain that we can really get is in terms of standby heat loss. How long are we holding in that specific temperature inside that tank?
Right.
The more we can control that standby heat loss, the higher that we can raise those EFs. And that's really what we're trying to accomplish. Now, as I said, as those larger tanks, because of the form factor, because these tanks are so large, you really can't control that standby heat loss enough to reach the type of numbers that NAECA III says we need to hit on these larger tanks, that 1.98. You have to change technology. That means we're going to have to move into heat pump technology in order to hit those type of numbers.
And this doesn't apply to just us. This is everybody.
This is across the board. This is any water heater that is manufactured after April 16, 2015. Everybody has to comply.
Okay. All right, so yeah, you were talking about them getting a little bit larger now. Since we can't do anything with the thermal efficiency, we can't make it put any more heat into the water, really. We're going to have to do something. So we have to. What are we doing? I'm assuming it has to do with that energy efficient foam.
Yeah, it does. Again, we're talking about standby heat loss and how we control that standby heat loss. So there's really two ways to effectively do that. And it comes down to insulation, right? The more insulation we can put around the heater, the longer we can hold that in. And again, raise those EFs by doing so. Now, we got a couple of ways that we can do that. One is we can just add the additional foam inside the jacket, right? Put more foam around that inner tank between the jacket and the tank. Now, that means that the water heater is going to get a little bit larger because of the additional insulation, about 2 inches across the board. Now, there's a second option. Instead of putting that insulation on the inside of the jacket, we can also put it on the outside of the jacket in terms of an external blanket. We can also do that. So we really have two options in terms of controlling that standby heat loss, and we're going to use both of those in the product line.
Okay, but when we're talking about anything over 55 gallons, now that's the difference. Now
that's the other deal.
We're adding more insulation. That's not going to be enough, would it?
Not once we get above 55, because of the EF standards that NAECA III invokes. Again, that over one, that 1.98, 1.97. There's just no way you're going to get there just by controlling standby heat loss. You can't do it. So the other thing is, once we get above 55 gallons, again, we talked about changing of technology. We have to go into a heat pump technology. What you're going to see now is we've introduced a couple of additional heat pumps into the product lineup. We have the 66-gallon and the 80-gallon tall and short that go along with the 50-gallon that we've always had.
Okay, so let's talk about how we're achieving, the actual insulation and the option of, the external, the blanket. Well, let's talk about the blanket, because they've been around. I mean, we've seen blankets before.
This is nothing new in the industry. I mean, the aftermarket has always sold blankets that you put on the water heater after the fact. There's 100 manufacturers that have offered those throughout the years. That's basically what we're doing. This is a standard blanket here. This one's in the wrapping. This is what you're going to get inside the carton.
Okay.
Once you buy the water heater, if you get the blanketed version, again, there's two options to these heaters. You can get the standard NAECA version that has the insulation already built into the heater and built into the form factor, or you can get the NAECA III blanketed version, which is a smaller form factor, and we're going to put the blanket insulation on the outside. But this is what will be inside the carton. And you're just going to open this up, unwrap it.
So this is in the box, just free
this
in
is
the
in the box.
Okay.
And you just want to unwrap this. If you do cut it with a knife, just be really careful. You don't want to cut through the blanket material. You only want to cut through the outside wrapping, so be careful about that. But once you get this opened up, what you're going to see, this is the actual blanket material itself. Now, again, we talked about the aftermarket with these. There's been a ton of these throughout the year in the aftermarket. I would say that most of them were kind of a little bit cheesy. Pretty thin, really didn't have the R factors, but that's really not what they were trying to achieve. There wasn't a magic number at that time that they were trying to hit. But now we are with NAECA III. So engineering has put a lot of effort into the blanket. Now, what you're going to see here, notice that we have a 3-inch fiberglass blanket. Notice that we have a vinyl covering on both sides. Now, the cool thing about that is it makes it extra durable. If this has to be taken off for any reason, servicing or something like that, this can be taken off and put back on without damaging the actual blanket. So having this vinyl on both sides is a really cool factor. Plus, if you're sensitive to the insulation material, makes you itch and stuff like that, the fact that there's vinyl on both sides will help control that. I don't know about you, but I know that if I touch this stuff, I'll be itching for 3 days.
It gets all over our
it gets everywhere. It just keeps multiplying. So
now when you put the blanket on, is it going to be a problem if we have to push it up against anything? Is that going to affect the blanket?
That's a really good question. We get that a lot. And people say, well, what if I don't have room for the blanket because there's a pipe there or it's up against the wall or something like that? It's not a big deal. The blanket itself is compressible. You can compress a specific area of the blanket and still maintain the insulation properties on the rest of the blanket. It's not a big deal. If you think about it, a water heater is round, right? It's not square. So when you slide it up against the wall, there's not a large amount of surface area that's going to be touching the wall. We're only talking about, maybe an inch contact patch down the vertical length of the water heater. So you can compress it in that one specific area, no big deal, okay? So no problem at all.
So this comes in a kit, and you're getting, what I'm assuming you're getting warning safety stickers, you're getting instructions too.
Yeah, the blanket's going to be in two pieces. You're going to get one larger piece that wraps around the actual tank itself, and then you're going to get this head piece that goes over the top. Again, we're trying to control that standby heat loss as much as we possibly can, so we're wrapping this heater as tight as we can. You also will get a set of instructions that comes along with the blanket itself. This will kind of walk you through the process of how to put the blanket on. There's a couple of pieces of tape in there to help hold that thing. But this will walk you through all of those steps.
Yeah, and it says there all the safety labels are going to be pre-applied. They'll be on the
they'll be on the outside of the jacket, so all of those scald warnings, the little guy that's in hot water and hand burnt and all those kind of stickers that we have to put on water heaters today. All those will be on the outside of the jacket, so when you put it on, you'll still maintain those stickers.
Okay, and if you need help, you can always call our 800 number. We'll be more than happy to help you out and kind of walk you through the process if you're having any trouble or anything. But let's kind of go over some of the water heaters and kind of what's changed and what our options are here.
Yeah, we talked about form factor, right? Form factor is changing, and this is where most people tend to panic and they say, well, oh my God, the water heater is bigger, I'm not going to be able to put it in the same spot. Most of the time, it is not going to be a big deal at all. Almost always, that new NAECA III unit is going to fit in the exact same place that the old one, with a couple of exceptions. And if you just happen to be in that one of those exceptions, we have some options there, okay? So don't worry about it. But let's look at the actual form factor so we can kind of tell exactly what is changing. Let's look at a 50-gallon tall, okay? Pretty standard unit. If you had a 50-gallon tall previous to NAECA, that unit would have been 54 inches height and 20 inches in diameter. Let's look at our first option here is our 50-gallon tall. This is our standard NAECA III, so the insulation is built into the jacket.
Okay.
That unit is 60.5 inches high, 22-inch diameter. Okay, so we gained 2 inches there.
It's just a little taller.
Just a little taller and a little bit wider. Now we see our second option. Notice that the one right under that says blanket, 50-gallon tall with a blanket. That one is 60.25 inches tall and 21 inches in diameter. So we're getting a lot closer to that form factor. And again, we're just gaining that additional insulation on the outside of the jacket as opposed to inside the jacket. The big thing to notice there is, again, that 66, that 80, and that 120. Those are no longer going to be offered in a standard electric. That means you're going to have to look at heat pump. If you notice there's a discontinued but C heat pump.
Yeah, and when you're talking about the 30 and the 40 now, that's not going to be available with the blanket in the tall models.
In the tall model, we'll go through the talls and the shorts and all the different ones, and you'll see which one has a blanket and which one of them don't. It's not always a direct replacement blanket, non-blanket.
Right.
But in most cases it is. Most cases you can get a blanket or a non-blanket.
Yeah, because most of the time when you have a tall water heater, you usually have enough room around the heater and above the heater to make it work.
Right.
So, what about the short models? I mean, I know we've got different models here, but let's talk about the short models.
Yeah, here's our short models here. Notice your 30-gallon short. The pre-NAECA unit had a 20.5-inch diameter. Our standard NAECA has a 22, or our blanketed version is only 20. So we're actually smaller than the original form factor on diameter, which is great if you have some space concerns. Gained a little bit of height. A little bit of height there, and again, that is a brand new unit. Hasn't been offered previously. And then your 40 and 50-gallon there is just a standard NAECA unit. And they pretty much get about 2 inches larger across the board. Okay,
so again, the 40, 50 won't be available with the blankets, just the 30 short.
That's right.
Okay. What about our low boys?
Low boys. This is always a big question. What about the Lowboy units? Our 30s and 40s we see here, you still have both options. You can either go with the non-blanketed standard NAECA or the blanketed NAECA version. The big deal with Lowboys is that 50-gallon low. Right now, that 50-gallon low is not offered. And then we look at our side connects. Again, 30, 40, pretty much same story. You can either take the blanketed version or the non-blanketed version. And again, that really comes down to whether or not you have some space requirements that really dictates which one of those you need. But you have those two options.
What about the mobile home electric water heaters? I know that we make mobile home electric
Yeah.
water heaters. Did they do were there any changes to?
A little bit, not real dramatic.
Okay.
If we can look at the graphic here and see, here's our before April 16th, our 30-gallon low and tall, and then our 40 shorts. We went from a 22-inch diameter on the 30 low to a 22-inch diameter on the 30 low post NAECA. But again, that's a blanketed version. We see that little asterisk there. It tells us that that's a blanketed heater. Now, our 30 tall went from an 18 to a 19.
Not
and
much
then
difference in
not a
both of
lot.
those.
And our 40 short, again, those short models, because of the form factor of those, they're going to get a little bit larger. That raised about 2 inches.
Yeah, so I mean, there really wasn't a lot of change in the mobile homes. So let's kind of talk about, you know, if we're replacing our water heater, and I've got an electric water heater, let's talk about some options that kind of walk us through it, because that's what really we need to know.
Yeah,
is what we need to do.
Yeah, pretty much like we talked about. Regardless of your application, we've got an option that's available for that. And form factor is the big driver behind that after how much hot water delivery it takes. So those are the two things that we have to look at in terms of options and what heater is going to be able to go where. So let's look at here. Let's say we take a 50-gallon tall. That's a pretty standard unit. If you had a 50-gallon tall electric, previously this was a 54 inches tall with a 20-inch diameter. Now, if you're going to replace that unit, your first option would be, again, your standard NAECA unit where the extra insulation is built into the form factor itself. That unit's going to be a little bit taller. It's going to be 60.5 inches tall with a 22-inch diameter, so we're gaining 22 inches. Now, in most cases, this is all you're going to have to worry about. In most cases, this additional 2 inches in diameter is not going to be that big deal. You take the old heater out, you put this new heater in, bada bing, no big deal. Now, if you do run into some space restraints, then your next option is going to be, we have a 50-gallon tall with a blanket. Now, that unit's going to be 60.25 inches tall, 21 inches in diameter. Again, we're getting a lot closer to that original form factor of the old heater, so if spaces are concerned, you can go with that one. Now, there is a fourth option if space is really a concern. And we just absolutely cannot use that 21-inch diameter with the blanket. It's 20 was the old one, and we have to have 20. There's no ifs, ands, or buts about it. What you can do is actually go down in size, go to a 40-gallon tank. Now, I know what you're thinking.
Yeah.
Now, you're thinking, well, wait a minute, Jason.
Now I'm not going to get enough hot water.
Yeah, you're telling me that I'm going to take my 50 out and put a 40 in. Now I'm not going to have enough water. It's actually not the case. Because by going with that 40, the key is adding a mixing valve. If we have to maintain that 20-inch diameter and there's no way around it, we can move one step down in size, go down to the 40, add a mixing valve. What that mixing valve allows us to do is now we can adjust the tank temperature to whatever we want. Right? Because the thermostatic mixing valve is going to control the outlet temperature of that water heater down to 120. That's where we're going to set the mixing valve to. That would allow us to store at 160 if we wanted to, because we're raising the temperature inside the tank. To get to that optimal shower temperature, we're using a whole lot less water.
Yeah, we're going to use less hot water and add more cold water to that.
By adding a mixing valve, you can effectively increase the size of the water heater by one size. That means by adding a mixing valve, you can take a 40 and make it seem like a 50. Make a 30 seem like a 40, just by adding the mixing valve and raising that tank temperature. So if you have to maintain that 20-inch diameter, your last option would be go down to a 40, put in the mixing valve. You maintain the same diameter form factor that you had before, and you're still going to get the same amount of hot water as you had out of that 50.
Yeah, and you know what? That sounds like a good option for any water heater, actually.
It really is, especially when we look at current standards and current codes. ASSE 1070 actually says that we should be using mixing valves anyway. That code says that the that the water heater should not be the only control for temperature for the home. Now, what does that mean? That means you need a mixing valve. That means you need an external temperature control source. So we really should be looking at this anyway. Even if you didn't have space constraints and you had a 50, but you just wanted more hot water out of it, go with the mixing valve. Turn that tank temperature up. It's
You'll
a great
use less
option.
hot water.
You'll use less hot water.
All right. So let's talk about what if I have a water heater that's over 50 gallons. I mean, now I mean, they don't make them anymore, so what do I need to go? When you're talking about heat pump, well, let's talk about that option.
Yeah, that's the big concern. We talked about when you get into that 80-gallon standard electric, what do I do with that? We don't have a NAECA III version of that 80-gallon anymore because it's just impossible to hit those type of EFs, that 1.98 that we were talking about. We have some options for that as well. Let's say today you had a standard 80-gallon tall. That unit was 60.5 inches tall with a 22.5-inch diameter. The replacement for that, if we were going to go with the heat pump, is we can put in the new 80-gallon heat pump that's 68.5 inches tall, 26 and 3/4 diameter. So it's a little bit taller, a little bit bigger, but again, that would be a direct replacement. If we have to have 80 gallons of storage, this will give you 80 gallons of storage, still meet that requirement. Plus, you get a huge payback for change of technology. We'll talk about that more in just a second. But there are some huge benefits by moving to this technology. You may have to do it because of NAECA III, but that could be a blessing in disguise because of the payback on these types of units are so great. Again, we'll talk about that a little more in just a second. Now, if that's not an option, let's say your customer doesn't want to change technology, doesn't want to go with the heat pump version. The other option is dual 40s. We take that original 80-gallon and put in dual 40s. We're maintaining the same storage capacity as we had before. We can get two 40-gallon NAECA approved units. The only thing you have to worry about here is it is going to take a little bit of extra piping, and of course you have to have the space for it. Again, we talk about the form factor being a big driver behind which heater you're going to choose. If space is not a concern, sure, put in two 40s. The cool thing about this option is, years down the road, you get one heater go down, you're still making hot water with the other one until you do that replacement. So that's not a bad option as well. Now, we do have a fourth option here as well. Again, we've talked about this already, and that is, again, going to the mixing valve. By reducing the storage capacity and putting in a mixing valve. If you have an 80-gallon in place today, you can replace that with a 55-gallon with the mixing valve, okay? Again, if we use, say, a 55 tall, a NAECA-approved unit, 50 tall, we're looking at 60 on the height, 24 inches in diameter. Again, we're getting really close to that original form factor of that 80-gallon tall that you had before. The cool thing is with that mixing valve, we can actually get really close to the first hour delivery and really how much usable hot water are we getting out of the tank. We can get close to the same thing that 80-gallon was providing out of that 55 by using a mixing valve.
The mixing valve is a wonderful thing. And we actually recommend a point-of-use mixing valve at each point of use in the home. That way, in case something does happen to one of the mixing valves, if you have a whole house mixing valve, there may be a chance when the mixing valve may not work, then you have no hot water at all. And the point-of-use will kind of help you out.
Yeah, you could have a failure. The other big benefit of going with point-of-use is now I can determine what temperature I want to send to what area, right? Let's say my dishwasher. I want hot water at my dishwasher. I really want above 140 degrees for sanitary purposes at a dishwasher. By using point of use, that will allow me to send 140 to the dishwasher and 120 to the faucet. So there's a couple of advantages by going with point of use. That's what we would really recommend is going with point of use mixing valves.
Yeah, and when we're talking about the heat pump, really the 66 and the 80-gallon heat pump, we make a 50-gallon heat pump as well. The thing about those is, and you were talking about, the energy factor on those is 2.74, 2.72, so they're very efficient.
Absolutely.
Extremely efficient. The one thing about that, in the way a heat pump works, is it's taking out that room air and actually putting that heat from the room air. Yes.
Free heat.
Putting it into the water. when it does that, you got to have enough space available, free open space available. But that doesn't mean that, what it say on the last slide, it said 700 cubic feet of free space. Now that doesn't mean the room has to be that way, because you could put it in a room with louvered doors that's that's open to an open space. But they are very, very efficient, and again, what it does is it takes that heat from the room, puts it into the water. Little bit slower on recovery, but we've got electric heating elements on there as well.
Yeah, it does have backup. It's got 3 heating modes. We can run it in hybrid. We can run it in efficiency, or we can run it in standard electric.
Yes.
Let's say groundwater temperature is so cold, we have a high demand for hot water, then this thing will just come out of hybrid altogether, go into standard electric, and meet that demand until that demand is no longer there. Then it'll go back to an efficiency.
Right, or when you're in a higher demand, like Thanksgiving, Christmas, when you got people around, you can put it in that electric mode. It'll give you a little more hot water, and then it'll automatically go back in.
Again, the only thing you have to remember here is because it is basically stealing the heat out of the air, you just have to make sure you give it enough air.
Yep. And again, on those heat pumps, if we look at the chart here, where we're going with the 50-gallon tall, we've got how tall that is. It's 63 inches high, 22 inches wide. There's not much difference between the current model and that 50-gallon heat pump.
It's not too far off. If you have a customer who decides, let's go ahead and change technology and take advantage of those benefits that the hybrid gives you, or the heat pump technology gives you, we're getting really close to those form factors. The big key here, look at those energy guides.
Yep.
That's the huge takeaway by going to this type of technology. Notice that our standard yearly cost of operation for that standard electric, this particular unit that we're looking at, is $613. Compare that to this particular heat pump unit that we're talking about is $192.
Yeah,
so you can see how big of a savings that you're going to get. That's the deal with heat pump. You tell me what energy costs in your area, I'll tell you what date that heater's free. That's it. That's what it comes down to. How much am I saving? What is the cost of ownership of the product? Because those are things that we have to think about, not just front-end costs.
Exactly.
Because that's not the only cost associated with the product. What is the cost of ownership? And by changing this technology, yes, there is a higher investment up front. But again, you tell me what energy costs in your area, I'll tell you what day this thing's free.
It's a great payoff on that, yeah. Now, I know that with these changes, we made some changes across the board to all of our electric water heaters.
We did a little bit, and in our gas show last month, we talked about some of the product standardization changes that it kind of went in across the board that related to all products in general, like the
drain valve.
The drain valves with the ball valve now and pass-through design. Our dip tubes that are now a combination nipple dip tube design. We talked about all of those, but there are some things that are specific to electric. We want to cover those well, and just to keep you informed. Again, these are not NAECA III related, but because we were making changes to the product because of NAECA III, now is a good time to go ahead and do the product standardization. One of the things you're going to notice is the junction box on top of the water heater. We have went from the design that you see on your left to the design that you see on your right. The one on the right was a Legacy Johnson City design, and we made both. Depending on where the unit was produced, you would see either one of those. So due to product standardization, we're going to go with that one you see on the right there. That was the Legacy Johnson City design.
Okay.
The next thing is our thermostats. Historically, we've run 2 different types of thermostat. We've run the thermal disc as well as the APCOM thermostat. So depending on where that unit was manufactured, it could have either one of those thermostats. Now again, because of product standardization, we decided to drop the TOD, stay with APCOM across the board. So now regardless of where that unit was manufactured, you're going to get the exact same thermostat.
Yeah, that makes a lot of sense. Yeah.
The next thing is elements. This is a big deal too. This is a cool feature. On our standard electric units, now come standard is going to be a copper upper with an incloy lower.
Okay.
And what we mean is that incloy has an incloy coating on the elements, a zinc coating. Now, what's the big deal there?
Yeah, so I was gonna, what is the benefit for that?
Yeah, it just means that the element's going to last longer, especially in heavy sedimentation.
Right.
Really hard water, those type of things. This incloy element is going to last a lot longer. So it's going to come standard on that lower.
Okay.
Right? Your lower does the majority of the work. It's also where all that sediment falls as that hot water precipitates.
So you need it on the bottom.
Yeah, the bottom's where you need it. So it just means that the water heater is going to have less servicing over time by going with that incloy on the bottom.
And those are our standard water heaters.
Yeah, that's across the board. Everything will be copper upper, incloy lower.
Okay.
Now the other change you're going to see is notice that premium 1010. We talked about conservationist early on, and the big thing that separated the conservationist from the rest of the units was the energy efficiency of that product. Now that everything has kind of come up to that level across the board and everything's kind of running that 0.95, so what is the differentiation now between our higher end model and our standard model? Well, our premium 1010 now is going to come with dual incloy, which means you're going to get this incloy element on the top and the bottom. The other thing is also a technology change. You're going to see what's called the smart version.
Okay.
We're basically going to come away from the electromechanical thermostat that we see here and go with an electronic thermostat.
All right.
It's got eye level controls, those type of things. So be on the lookout for that product as well.
All right, and now there were some exemptions to NAECA III. Let's talk about those.
One of the exemptions was the tabletop units. Because of the form factor of a tabletop unit is so drastically different than any other form factor across the product line, NAECA III agreed to take this type of a water heater completely out of scope of NAECA. So you're not going to see any changes there in terms of NAECA III requirements.
Okay.
But there is some product standardization changes that we just want to make you aware of as well. Again, previously we've run two different versions of this heater. We can see the images here. You see an Ashland City version and a Johnson City version. So again, depending on where that product was made, it looked a little bit different. And we're talking about the access panels and those type of things.
So we're going with the one on the right.
We will be going with the Johnson City version across the board. Also, all manufacturing of the tabletop units will transition to Johnson City. So again, regardless of where that product comes from, you're going to get the same design across the board.
And another thing that we've done is we're now going with one color.
Yeah, everything is going to be one color across the board, regardless of what brand you're looking at. Everything is going to be a standard color. It's called the window gray, and we see an image there. That's going to be, so if you're used to seeing the lighter gray or the, I think we had about 3 different shades of gray at one time, depending on where the unit was.
50 shades of gray.
That's right. Well, easy, Jerry. So depending on where the unit was made, it could be different colors. Now that's going to be the same across the board. So again, no matter where that product was manufactured, you're going to get the same color jacket, and they will all be that window gray. That will be phased in over the course of this year.
Well, that about covers from here. What we're going to do now is we're going to look at some of your questions and kind of go over those. And
yeah, let's take some questions.
Let's take some questions. All right, I think we have one question, and it refers to laying a heat pump on its side. You're talking about how long you can lay it on your side. You know, we really wouldn't like you to lay them on the side, you know, but I know that you probably have to in certain situations. I would probably just set it up and let it sit there for a little while if it's been on its side for an extended period of time. Then when you plug it in, it's going to take about 8 minutes for it to go ahead and start, so that's letting everything kind of settle. So, you know, if that does happen, you know, I would probably set it up for a little bit of time and then start it up.
Yeah, everything should work itself out during that 8-minute startup period.
Yeah, it's going to do a lot of diagnostic check.
Yeah, but we would recommend not setting it on its side. If you can avoid doing so, please do so. But we know that sometimes there's just no way around it because of the way you have to transport it or whatever. You may have to, but everything should work itself out during that 8-minute warm-up cycle.
Yep. But really, that about covers it today. If you have folks who missed this broadcast, a recorded version will be posted online in about 24 hours. There's a link in the email announcement. And before we go, I'd like to mention Contractor Rewards. You can earn Contractor Rewards points for buying A.O. Smith products. Purchase an eligible product that has a yellow rewards code sticker, Enter that code online and shop for thousands of name brand items. Simply go to contractorrewards.com and enroll. It's free and easy. And if you're not yet a member, sign up today. If you already are a member of Contractor Rewards, you get points just for watching this class. There's the Contractor Rewards code. Well, that's our show for today. You know, I mean, electric water heaters, really, you know, you've got your options available, so it shouldn't be that big a deal.
Yeah, I mean, like I said, I mean, NAECA gets a lot of publicity right now because we're in that mode. But the fact of the matter is, it's really not that big a deal. Regardless of the scenario, we have an application that'll fit that. Most cases, it's extremely simple.
Right.
You just put in the new NAECA heater. There are some circumstances where we have to change the heater, look at some different options, add a mixing valve, whatever the case may be. But those are pretty limited. You're not going to run into that all that often, but if you do, we've got an answer for you.
Yeah, we've got options for you. But that's our show. If you have any questions about anything we've covered here, just email us at university@hotwater.com. And you can follow us on Twitter and Facebook to get updates for next month's show and other university news. Don't forget to check out our new website, university.hotwater.com, and that's really where you are right now. So take a look around on that website. If you need training, you just go to the website, check out all the trainings we have available. You can even register for classes at the website. But been fun, and I guess we'll see, I don't know, we'll be talking about next month's show. I mean, so take a look at Twitter, follow Twitter and Facebook, and we'll keep you up to date on next month's show.
That's right.
All right, but for Jason Leonard, I'm Jerry Winslet, and we'll see you next time.